All right, let's solve a system with substitution. Okay, the very first thing that you need to do is get one of the variables isolated. It could be x or y, it doesn't matter. But I'm going to choose this second equation here, and I'm going to isolate my x because there's no coefficient in front of it. So this will be easy to isolate by moving my 2y. So in order to get x by itself, I need to add 2y to both sides so that this becomes 0. Okay. And my equation is now x equals 11 plus 2y. You can have 2y plus 11, keep the symbol with the term, and it's okay to have them in the opposite positions, but make sure you keep the symbol with the term. Now the next step is to substitute this expression into the opposite equation for the variable that I've isolated. So it's going to get substituted right up here into my x. Negative 7 times this, because this is now replacing my x. 11 plus 2y, finish the equation, minus 2y equals negative 13. Okay. See, those are the exact equations, but I substituted 11 plus 2y for the x. This was multiplication, so this is multiplication. Okay. Here I have a distribution. Make sure you distribute to both terms. Negative 7 times 11 is negative 77. Negative 7 times positive 2y is negative 14y. Drop down my negative 2y, I haven't used it yet, equals negative 13. These two terms are both y terms and they're on the same side of the equal sign, so I'm going to combine them together. Negative 77, and now I have negative 14y minus 2y. You can think of this as negative 14 minus 2, but they are y terms. Well, negative 14 minus 2 is negative 16. These are y terms, so this is negative 16y equals negative 13. I have a two-step equation here. This 77 is negative, so in order for me to turn it into a 0, I have to add 77. Whatever I do to one side, I must do to the other. These now cancel out. I have negative 16y equals, and now I have some integer math here to do. I have a negative 13 plus a positive 77. And that's going to be 64. I almost have my solution for y. Some of you can do this mentally, but you know that I'm always asking you to show all of your work. So show that you're going to divide off a negative 16 from both sides. This becomes a 1y. Y equals, and 64 divided by 16 is 4. But a positive divided by a negative is negative 4. Okay. See, I don't have another highlighter here, so I will just use a ballpoint pen. Now I need to take this negative 4, and I need to substitute it back up into one of these two equations, and it's y, so I'm going to substitute it either here or here in one of the positions, whichever one looks more friendly to me, and I'm going to choose this one. Okay. So I have x minus 2 times, but my y is now replaced with a negative 4, equals 11. This is a negative 2 times a negative 4, so x plus 8 equals 11. Subtract 8 from both sides, and I have x equals 3. Remember that your answer to a system of equations is always your ordered pair. So my ordered pair is 3, negative 4. You could check this solution by either graphing both equations and making sure this is the point where the two lines intersect, or you could take these two, x is 3, y is negative 4, substitute them back into both equations and make sure that they both work. They both have to make true statements.